All right, we're starting our next chapter, and in chapter 9, we are going to talk about specifically right triangles and other types of triangles, and it starts with the Pythagorean theorem. That's the first one we're going to chat about. And this, if you remember, is a squared plus b squared equals c squared. And in the Pythagorean theorem, it tells us that if we have a right triangle, then this will occur. And a and b, if you remember, are called the legs. Those pieces make up the right angle. That's kind of the hinge. The right angle is the hinge of the A and the B of our legs. And if you remember too, the A and the B, it doesn't really matter which one is in which place. Like this doesn't always have to be the A right here or the B. I can flip them around. The really important piece is the C, and the C is the hypotenuse. And the C has two things. It is always the longest, it's the longest side, and it is always across from that 90-degree angle, right across from there. So sometimes you look at a triangle and you're having a hard time telling which one the hypotenuse is. That's some of the ways that you can figure that out. It's always going to be the longest, and it's always going to be across from the right angle. Okay, so a couple of things that might help us in our quest as we are solving these are some triples. And Pythagorean triples essentially are just shortcuts. We've already done the work on these, that 3 squared plus 4 squared is equal to 5 squared, because 9 plus 16 is equal to 25. And since that's true, this means that the Pythagorean theorem works. So if I see a triangle that has sides or legs of 3 and 4 and has an hypotenuse of 5, I know for sure that it's 1, a right triangle, and 2, I can use these measures to help me in my solving. And so some of the things that they've done is then kind of classify this into other groups and say that if I have a 3, 4, 5, it would also work for a 6, 8, 10 or a 9, 12, 15. Working in those same ratios, it's still going to be a Pythagorean triple. Or again, sometimes we're going to see variables come into play with these. So these are some common ones, which just kind of help save us time. And the same with this as well. So a 5, 12, 13 is also called a Pythagorean triple because 5 squared plus 12 squared is equal to 13 squared. And again, they just kind of showed you this family of the 5, 12, 13. There's 10, 24, 26. And again, you can kind of just see some others. And these just kind of are familiar. They come up pretty often. So it's nice to have those written down. Now we're going to look at the converse of the Pythagorean theorem. And remember, we're essentially switching the if and the then in a converse statement. And so it's saying that if this formula works, if a squared plus b squared equals c squared is true, then I know I have a right triangle. Whereas the theorem itself said if I have a right triangle, then a squared plus b squared equals c squared. Again, these guys just flipped it around for the converse. Then we have the Pythagorean theorem in equalities. So sometimes we're going to see triangles that aren't right, and we can still use the Pythagorean theorem to our advantage. So this time it's working with inequalities. It's not going to be equal to c squared. It's going to be less than or greater than. So if I take a look at this and see that if I do my legs, a and b, and I take a squared plus b squared, if that sum is larger than what I get for c squared, then the triangle is acute. If I take my two legs and I take a squared and b squared and I take and add them together, if that sum is less than what I get for the c squared, then it is obtuse. Then it is an obtuse triangle. The clue for today, so if you've been listening this whole time, hopefully, the clue for today, would you please message me on Canvas and tell me your favorite subject in school? And you can't say lunch, and you can't say you don't have one. What's your favorite or the one that you dislike the